Hello learners, welcome to today's discussion. Today we are going to look at the preparation of ammonia gas, and later we look at the manufacture of nitric 5 acid. And the question we have reads, the diagram below shows an incomplete setup used to prepare and collect ammonia gas. We have solid T plus calcium hydroxide, and when the two are heated, they produce ammonia gas. So the first part of the question is name solid T. In solid T can be ammonium chloride, you can use ammonium sulfate, you can also use ammonium chloride, ammonium carbonate, Roman 2, write an equation for the reaction that occurred when a mixture of T and calcium hydroxide was heated. So we take ammonium chloride, solid, we react it with calcium hydroxide, and this reaction will produce calcium chloride. We have ammonia, which is a gas, plus of course water, which is a liquid. We can balance the equation by writing 2 behind ammonia, 2 behind water, 2 behind ammonium chloride for the equation to be balanced. Next, Roman 3, complete the diagram to show how dry sample of ammonia gas can be collected. We are going to complete the diagram as follows. When the mixture is heated, we have the diagram that looks like this. We have the diagram that looks like this. This is where we have the drying agent for ammonia, which is quicklime. We have quicklime. Then after it has gone through the drying tower, it is collected by upward delivery because it is less dense than air. Up here we have ammonia gas. This is ammonia gas. Then this is quicklime or calcium oxide. Then we can call this the drying tower. By so doing, we'd have completed that diagram very well. B, ammonia gas is used to manufacture nitric 5 acid as shown below. We have ammonia and air, which are reacted together to form compound U, which is taken to the cooling chamber and comes out as compound V. Then compound V gets into the absorption tower, where it is reacted with water and air to form nitric 5 acid. In this case, let us look at the summary of the reactions that take place. We have ammonia gas reacted with air, which is oxygen, and the reaction produces nitrogen 2 oxide gas and water, which is a liquid. The nitrogen 2 oxide gas is oxidized further by air to produce nitrogen 4 oxide, which is compound V. Then, of course, nitrogen 4 oxide is dissolved in water to form a mixture of two acids. Let us look at the questions. Name the catalyst used in the above process. The catalyst used in the industrial manufacture of nitric acid is platinum. Platinum catalyst. Identify compound U when we react ammonia and air in the presence of platinum catalyst, we get nitrogen 2 oxide. Roman 3, write an equation for the reaction that took place in the absorption tower. In the absorption tower is where we have compound V, which is nitrogen 4 oxide. We have water, which is a liquid, plus the oxygen gas to produce nitric acid, that is HNO3. Roman 4, ammonia and nitric 4 acid are used in the manufacture of ammonium nitrate fertilizer. Calculate the amount of fertilizer manufactured per day if the daily consumption of ammonia is 2400 kgs. Assume that the factory is 100% efficient for us to get 3 marks. So the first thing we need to do is to do an equation between ammonia gas and nitric acid, which produces ammonium nitrate fertilizer. So if you look at the equation, you realize the ratio of ammonia to that of ammonium nitrate is 1:1, and now we can begin by calculating the moles of ammonia. To get the moles of ammonia, we have the mass that is used, that is 2400. You multiply by 1000 to change them into grams, divide by the relative molecular mass of ammonia. That is, nitrogen has a relative atomic mass of 14. We add 3 of hydrogen for us to get 17. And this one gives us 141, 176.5 moles. This number of moles are the same as the number of moles of the fertilizer. In this case now, let us get the molecular mass or the relative formula mass of ammonium nitrate, and the relative molecular mass of ammonium nitrate is going to be 80. That is, we have 2 nitrogens, that is 14 times 2, which is 28. We add hydrogen, we have 4. We add oxygen, we have 16. We multiply by 3, which is 48. The total would be 80. So let us get the mass. Mass of ammonium nitrate will be equal to the number of moles, which is 141, 176.5. We multiply by the relative molecular mass, which is 80. We divide everything by 1000 to convert them back into kilograms, and this one gives us approximately 11,294.16 kgs as the mass of the fertilizer produced in a day. That is, if the factory is 100% efficient. If the factory is 100% efficient, it means there is no wastage. Thank you for watching and welcome to the channel.